Every time you ask ChatGPT a simple question, somewhere water disappears. Not from your glass, from giant cooling systems keeping AI computers from overheating. By the end of this video, you'll understand why researchers are arguing over how much
water a chatbot really drinks. When people talk about AI's environmental impact, they usually focus on electricity. But electricity is only half the story, because behind every AI prompt is another resource, one we can't live without: water. And the numbers are so confusing that two articles can report completely different estimates, and both still be technically correct. To understand why, we need to start with something most people never see: the inside of an AI data center.
Forget the word cloud. Imagine a warehouse the size of several football fields, packed with thousands of servers running day and night. Those servers generate enormous heat, so much heat that,
without cooling, the hardware could fail. Many data centers use evaporative cooling, the same basic principle that cools your skin when sweat evaporates. Water absorbs heat. Water evaporates. The heat leaves with it. Simple, effective,
and surprisingly thirsty. Researchers estimate that US AI data centers are on track
to consume water at a scale that could
rival the annual water use of an entire small country. But here's where things get strange.
The water evaporating on site may not even be the biggest part of the story, because there's a second, largely invisible layer that most headlines skip entirely. So let's ask the question everyone wants answered: how much water does one ChatGPT prompt use?
One widely discussed estimate suggested that generating a longer AI response could be associated with roughly half a liter of water use. Other analyses put the number closer to a tiny fraction of a milliliter. That's not a small disagreement. It's a gap of hundreds, even thousands of times. So who's wrong? Possibly nobody. Here's the key distinction.
Direct water use is water consumed by the data center's cooling system. Indirect water use is water used upstream, including the power plants that generate the electricity powering those servers. Count only the cooling towers, and the number looks small. Count the entire electricity supply chain, and the number becomes much larger. That's why two fact-checked articles can publish dramatically different figures, and both be based on legitimate research. Now comes the important part. Even if you choose the smaller estimate, multiply it by billions of AI prompts every single day, across ChatGPT, Gemini, Claude, and every other system. Suddenly, a tiny number doesn't look tiny anymore. And answering your question isn't actually where AI uses the most water. The real spike happened long before you ever opened the app. Training a large AI model requires vast amounts of computation,
running continuously for weeks or months. Researchers have estimated that training a single large language model can consume water comparable to the annual drinking needs of hundreds, even thousands of people, depending on the model, the cooling method, and the local electricity mix. Then there's the twist that usually gets buried in the fine print. Many new AI facilities are being built in regions that already face water stress, parts of the US Southwest, India, and other drought-prone areas. How much water? It's whose water? To reduce direct consumption, some companies are adopting closed-loop liquid cooling systems
that can dramatically cut the amount of water evaporated on site. That's real progress, but it doesn't eliminate the upstream water tied to electricity generation, and it doesn't change where much of this infrastructure has already been built.
Why this matters. So should you stop using AI? Probably not. One prompt is a drop, literally. But billions of people, each adding one small drop, can create a very large river.
And most of that river flows completely out of sight. The bigger lesson is this. For years, we treated software as something almost weightless, just code on a screen. Modern AI breaks that illusion. Behind every answer is a physical system made of chips, electricity, cooling infrastructure, and water. Lots of it. The next time someone says AI is just software, remember this: somewhere that software is being cooled by real water. In a real building, consuming real resources. We spent decades worrying about the fuel that powers computers. Now, we may have to start worrying about the water that keeps them alive.
If this changed how you see AI, subscribe, because next time we're exposing another hidden cost that's even less visible: the human labor behind the intelligence.
And tell me in the comments, which surprised you more? The water used to answer your question, or the water used to train the model before you ever asked it?